measure heats of reaction, you carry out your reaction in an enclosed container, in an insulated container called a calorimeter. Okay. And so what you do is you mix your reactants and you just measure the temperature difference, the change in the temperature, T final minus T initial. Okay, so imagine you have separated reactants. They're all at the original temperature T1. You mix them in your calorimeter, and what happens? A reaction happens. So now you have mixed products in your calorimeter at a different temperature T2, right? Because as a result of the reaction, typically when you carry out a reaction, the temperature will change. Okay, so within that calorimeter, the temperature has now changed to T2. Your reactants have reacted. You now have a mixture of products. Q for that process and delta H for that process, for that step, is equal to 0. Why? Because your calorimeter is insulated, okay? Or we say it has an adiabatic wall. Okay, the process is adiabatic. Adiabatic, remember, means what? Something that doesn't allow heat to flow. So I have an adiabatic wall, so Q is 0 for that process. Okay, so suddenly your reaction mixture is now hotter or colder than it was before you mix the reactants. So now you imagine, okay, taking the products, which is now at a different temperature, back to the original temperature of the reactants before you mix them. What's Q for that? That's a simple formula, and there's no reaction here actually, right? There's actually no reaction here. All you're doing is you're changing the temperature of what you already have from the final temperature that you measured back to the original temperature. And you don't have to actually carry it out, you just imagine it happening. How much heat would be involved in that step? It's just going to be equal to C times negative delta T. What is C? This is going to be the heat capacity of the whole thing, right? So this is going to be the heat capacity of your calorimeter and its contents at that point, right? Why do I put a negative delta T here? Because I'm reversing my temperature change. So this delta T for this is actually T1 minus T2. That's the opposite of T2 minus T1. So this is the fundamental equation that you use when you're trying to measure heats of reaction. The heat of reaction is just equal to negative C times the delta T that you measured when you carried out the reaction. Okay? Another